this video, again, is still in chapter 6, benzene and its derivative. Okay, these are the learning objectives in the chapter of 6.3. However, we will only focus on the 6.3a, explain the electrophilic aromatic substitution for benzene. There are 4 reagents. And then explain the following reaction for the alkylbenzene, which involve 2 reactions, oxidation with hot acidified KMnO4 or halogenation. As like we mentioned before this, the reaction carried out by the benzene is electrophilic aromatic substitution. So when this happens, so we know that one of the hydrogen from the benzene ring will replace by the electrophile. So different from the alkene, the benzene also will react with the halogen. However, the catalyst that used is FeS3. It is not using the CH2, Cl2 or water. Okay, so this is why you need to remember the solvent as well or the catalyst. Another reagent, so since it is halogen, so either one can be partially positive. Okay, second reagent is react with concentrated nitric acid as the reagent, and the concentrated H2SO4 is added as the catalyst. The condition must be in 50 to 55 degrees Celsius. So for this one, we will know that the HNO3 nitric acid will have HO and then with NO2. So the bond will be break in between NO2 and the OH. So as we know, oxygen is more electronegative than nitrogen. So OH will be partially negative and NO2 will be partially positive. So for the RCl, that means the haloalkane, the bond will break between alkyl group and also the halogen, which is the chlorine in this case. So Cl is partially negative and the alkyl group is partially positive. Another one is react with acyl chloride, so similar case as well. The bond will break between the carbon and chlorine. So chlorine is partially negative and carbon is partially positive. So all these have using the catalyst. So if the benzene ring react with halogen, the process will be known as halogenation. If benzene react with nitric acid, the process is known as nitration. If benzene react with haloalkane with the presence of AlCl3 as the catalyst, process is known as Friedel-Crafts alkylation. And then last one, benzene, if react with the acyl chloride, process is known as, the name of the process is known as Friedel-Crafts alkylation. So as we mentioned just now, it is a substitution reaction. So the electrophile will be replace the hydrogen. So the electrophile is NO2, so that's why NO2. The bond is break between N and OH, so that's why the bond will bond to nitrogen instead of oxygen. So when react with the haloalkane, the alkyl group is the electrophile, so here also replaced by the alkyl group. When the bond break between the acyl, RC double bond O and Cl, so this part will bond to the benzene ring. So to keep in mind, the bond is break between carbon and Cl, so that's why the bond over here have to bond to the carbon. Tutorial question objective number 2. choose the correct statement for the reaction below. So this is a benzene react with the nitric acid with the presence of sulfuric acid to produce nitrobenzene. So as we know, benzene is undergo electrophilic aromatic substitution. So option A is wrong. The electrophile is H2SO4. Basically, the electrophile is the NO2 plus. It is an electrophilic aromatic substitution. Yes, involved in the reaction is not NO3 negative, but is the NO2 plus. So the answer is C. Okay, let's discuss one tutorial question. Question number 7. A few aromatic compounds P, Q, R are shown below. Use the following compound to answer the following question. Name the compound Q. So we have one substitute. This substitute is known as methyl. Alkyl group consists of one carbon, is known as methyl, and then attached to the benzene. So the name for compound Q is methylbenzene. So we no need to put the number 1 is okay because there is only one substitute. So definitely this substitute will be placed at the carbon 1. Show the mechanism how P can be converted to Q. So this one we will ignore first because in the previous slide we didn't learn about the mechanism. C. P is nitrated to produce R. So basically is a benzene ring, a benzene going to produce nitrobenzene. So state the type of mechanism means that is type of the reaction. Okay, so the type of reaction is electrophilic aromatic substitution. Okay, second part and write the reaction mechanism. This is not covered yet, so we are not going to discuss. So state the electrophile in the reaction. So as we know, the reagent used in this here is concentrated HNO3 with the presence of concentrated H2SO4 at 50 to 55 degrees Celsius. So we know that the benzene ring here have one hydrogen, and this hydrogen replaced by the NO2. And then here we note it as electrophile. So means electrophilic aromatic substitution. Means that in this case, the electrophile is NO2 plus. Objective question number 5. So when we see the formula C6H6, basically we know this is represented by a benzene ring. And C6H5 means that there is a benzene ring and then one of the hydrogen replaced by the CH2, CH3. So means that is from benzene to alkylbenzene. Benzene to alkylbenzene. So that means we are adding the alkyl group. So if we want to produce alkylbenzene, basically we are going to use chloroethane. Either is means that haloalkane. So and then for the condition, we didn't specify. So means that any condition is okay. And then the catalyst, as we always write down there, is CH3. CH3Cl for CH3CH2Cl and then AlCl3. So the catalyst is AlCl3. So the correct answer for question number 5 is donkey. Okay, there is another two reaction that will happen at the alkylbenzene. That means there is an alkyl group attached to the benzene ring. So the most simple alkylbenzene is this methylbenzene. So methylbenzene, for example, can react with hot acidified KMnO4 or is K2Cr2O7. So as we already know, when we see KMnO4, this one is oxidizing agent. So means that the methyl benzene will undergo oxidation. So basically, if undergo oxidation, the definition is gain oxygen, lose hydrogen. So we will notice that CH3 will become COOH. Okay, another one is related with the alkane. So we will notice that this CH3 have the properties similar with carbon-carbon single bond, which is alkane. Therefore, if you have the chlorine with the presence of UV, free radical substitution will be happen. This process will known as halogenation because the benzene react with the halogen. But as we know, this is a free radical substitution, so means that one of the hydrogen from the methyl group here will replace with the Cl. Therefore, the hydrogen from 3 hydrogen become 2 hydrogen, as one of the hydrogen replaced by the Cl, and the side product is HCl. Okay, now we look at here, oxidation only will take place at the benzylic carbon. So before we go in details, we need to understand what is the meaning of benzylic carbon. Okay, basically benzylic carbon is the carbon attached directly to the benzene ring. Directly to benzene ring. So we have 3 alkylbenzene over here. So this is the benzylic carbon. Okay, so we highlight the benzylic carbon with the yellow color. This one, the red color one, is benzylic carbon, and this one is benzylic carbon. Okay, every one of these only have one benzylic carbon. Next, we will look at here. They say that here, oxidation only occurs for the alkylbenzene with benzylic hydrogen. So what is the meaning of benzylic hydrogen? So the meaning for the benzylic hydrogen is hydrogen that attached to benzylic carbon. So for the first compound, let's say compound A here, we have 3 benzylic hydrogen. However, for this structure B, only have 1 benzylic hydrogen. And the structure C has no benzylic hydrogen. So when there is no benzylic hydrogen, no reaction happens. If you have benzylic hydrogen, no matter it's 3 benzylic hydrogen or 1 benzylic hydrogen, the product always will be the benzoic acid. So then you will ask, what is the remaining hydrogen? As here we have 3 hydrogen, and then here only have 1 hydrogen. So the side product can be the H2O. Then, if for structure B, how about others carbon? Because here we still have carbon. Yes, the carbon here will become carbon dioxide. Objective question number 4. The product of the reaction below is, where again, when we see hot acidified CaO4, so we know that this is undergo oxidation. So the oxidation only will happen at the alkylbenzene, which consists of benzylic hydrogen. So before we know which one is benzylic hydrogen, so this is benzylic carbon, and then this one also benzylic carbon. So this benzylic carbon have 3 hydrogen attached to it, means that here we have benzylic hydrogen. So for this benzylic carbon, we have 1 benzylic hydrogen and 2 alkyl group. So basically also have benzylic hydrogen. If there has the benzylic hydrogen, so it will undergo oxidation to form COOH. So the answer is A. Tutorial question number 5. outline the synthesis of benzene to benzoic acid. So we go to structure. Part A, from the benzene, it to goes to the benzoic acid. So as we know, benzoic acid is from the oxidation of alkylbenzene. So then from here we know that the benzene have to undergo Friedel-Crafts alkylation, which is, for example, CH3Cl with the catalyst AlCl3, at where it will produce a benzene, and then the bond will break between CH3 and Cl. CH3 is partially positive, so attached to the CH3. Then this methyl benzene will undergo oxidation using KMnO4, hot acidified KMnO4. Since it has the benzylic hydrogen, therefore will produce benzoic acid. Another one is the benzene and produce benzyl chloride. So from what the naming we learned in the previous video, benzyl is the one with a benzene ring with CH2, and then chloride is the Cl. So again from here we can see that there is a CH3, so we still can like 5A, benzene react with the haloalkane with the presence of aluminium chloride, and then produce a alkylbenzene, methyl benzene. So this methyl benzene, from here we can see that the part that have the changes is CH3 becomes CH2Cl, means one of the hydrogen replaced by the Cl, which here CH3 have the similar properties with the alkane. So here is Cl2 is CH2, Cl2, and then with the presence of UV. So one of the hydrogen will replace by the Cl. Okay, question number 8. The diagram below shows the reaction for the benzene and its derivative. So start from here is the benzene, react with a reagent 2, will produce nitrobenzene. So basically we know here is concentrated nitric acid with the presence of the concentrated H2SO4 as catalyst, and then the temperature is at 50 to 55 degrees Celsius. And then from here we can see this is a X, which can react with chlorine with the presence of UV, and then react with one reagent to produce benzoic acid. So basically we will know that the X can be the alkylbenzene. So we choose the most simple one. The compound X can be the methyl benzene. Okay, suggest how S can be prepared from benzene. Write an equation for the reaction. So means that we are going to write a benzene ring react with CH3Cl with the AlCl3 as the catalyst. One of the hydrogen from the benzene ring will be replaced by the CH3. So hydrogen from the benzene ring will combine and form the bond with the Cl. So this is called equation. Basically for the equation, you need to give the side product. What reagents are required to carry out conversion 1 and 2? So 2 we already discussed, and then 1, since this is the alkylbenzene, methyl benzene, so undergo oxidation to form benzoic acid. Therefore, the reagent 1 will be the hot acidified KMnO4. Name the type of reaction in 1. So type of reaction, benzene, one of the hydrogen of the benzene replaced by the NO2. So this is electrophilic, aromatic, substitution. Sorry, this is for the number 2. So number 1 is here, from the methyl benzene become the carboxylic acid. So this one, when we see there is KMnO4H plus heat, so this is oxidation. Okay, so we already done for the structure question D. So now we will go to name compound Y. So the methyl benzene react with chlorine and then will produce an organic compound Y, which the Y supposedly is the one of the hydrogen from the methyl will replace by the Cl. So the name for this compound is benzyl chloride. Okay, because the question is asked us give the name, not the structure. So you must write down benzyl chloride, then only we will get the mark. Tutorial question number 9. The diagram below show a reaction scheme for the methyl benzene. So when we look at the product and also the reactant, here only have one methyl group, but the product have two methyl group. So means that the reagent A also supposedly will consist of CH3. So means that we are going to use CH3Cl and then with the presence of AlCl3. What will happen when B and C heated separately with acidified potassium manganate 7? So as we discussed before, if we see acidified potassium manganate 7, means that the process is oxidation. So if oxidation consists of benzylic hydrogen, means that the product will become benzoic acid. So because of here we have two group of the alkyl group, so the B will become like this, and the C also same. There is two benzylic carbon, and each benzylic carbon has the benzylic hydrogen. So the structure of the CH3 will replace with the COOH. Okay, tutorial question number 7. The following scheme shows the benzene can be converted to benzoic acid. So based on the previous tutorial question that we discussed, so I think basically you already have the idea. The compound X will be referred to the methyl benzene. Tutorial question number 9. So from here we can see that this methyl benzene become the benzyl chloride. Okay, the structure for this part with a benzene ring and CH2 is the benzyl. So we know that one of the hydrogen replaced by the Cl. So X here actually basically is referred to the Cl2, and then the Y is represent the UV. Okay, so X and Y are UV and chlorine respectively. Option A seems like okay. Then if we have the UV, so we know that the reaction is free radical substitution. So electrophilic substitution reaction is not happening. So the answer is 1 and 2, B. So in this video, we already covered the reaction that will be carried out by the benzene, which is electrophilic aromatic substitution, which can react with 4 reagents to produce one of the product is alkylbenzene, and where the alkylbenzene can undergo oxidation and also the free radical substitution. So that's all for this video. In next video, we are going to learn about the mechanism of electrophilic aromatic substitution.